Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. Most end users, when given the choice, will ask to be provided with a standards-based certification test report. Such test reports prove a job well done by the installer and that the network cabling will support the application for which the network was designed. In fact, certification test results are required for long-term cabling system warranties. In addition to standards-based pass-fail certification test results, end users often request corresponding OTDR trace reports and end-face inspection and analysis. In the past, this meant 3 separate test reports. Now, however, FiberAll 7 series testers have been developed to use OWLView software that combines all 3 of these test results onto a single page, what we at OWL call a tri-report. OWLView integrates certification test results from the FiberAll 7 line of certifiers, OTDR results from OWLTREK OTDRs, and end-face inspection results from any fiber microscope able to capture end-face images. Tri-reports are just one reason to use FiberAll 7 series certifiers. This video will cover the compelling reasons to buy the FiberAll 7 BIDI bi-directional certifier over other certifiers on the market, including ultra-expensive copper fiber hybrid testers and traditional certifiers alike. The FiberAll 7 BIDI bi-directional certifier is a matched set of 2 identical optical loss test sets, one acting as the master unit and the other as the remote. This puts the FiberAll 7 BIDI in the same category as the fiber modules used on expensive copper fiber hybrid testers. Please note that OWL specializes in fiber optics testing, so the FiberAll 7 BIDI does not certify copper cabling. Technicians will still need to have a good copper certifier to test copper networks. That being said, there are some very good reasons why the FiberAll 7 BIDI certifier is a superior alternative to fiber modules. The key advantages to having a fiber-only bidirectional certifier is based on the fact that the fiber modules on the copper fiber hybrids cannot function when separated from the base testers. With copper fiber hybrids, fiber and copper techs would have to wait for each other to finish their jobs. However, if the fiber techs had their own bidirectional certifier, they wouldn't have to wait for the copper techs to finish testing. They can both do their jobs at the same time. This means the project gets done faster, and everyone can move on to the next job that much quicker. More jobs equals more revenue. If the copper base units are unavailable, such as for recalibration, then the fiber techs can't do their job either because the modules won't work without the copper base units. Having a separate fiber-only bidirectional certifier would at least let the fiber technicians do their jobs. Both of these advantages are compelling enough reasons to use a separate fiber-only bidirectional certifier in conjunction with a copper certifier. Another main advantage is that OWL certifiers are far less expensive than the copper fiber hybrid systems, even less expensive than the fiber modules alone. All of these reasons demonstrate that it is better to invest in the FiberAll 7 BIDI certifier instead of expensive fiber modules. In addition, by testing 2 fibers at a time, FiberAll 7 BIDI certifiers are a better alternative to traditional fiber certifiers which test only 1 fiber at a time. It should be obvious that testing 2 fibers at a time is nearly twice as fast as testing 1 fiber at a time. However, the other primary advantage of the FiberAll 7 BIDI over single fiber certifiers is that link length is measured during each test. When certifying a cable, link length cannot be avoided. Without a length measurement, there would be no way of knowing how much fiber loss to include in the fiber link budget. Since single fiber certifiers cannot measure length during the test, the length must be entered manually or measured separately during link setup as a secondary process. Regardless of how the length is acquired, the length measurement only applies to a particular group of fibers with identical characteristics. When moving to a new set of fibers with different characteristics, the length must be re-entered. This interrupts the flow of the test and slows down the testing process significantly, especially with low fiber count links. Measuring length during the test eliminates all of these disadvantages. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.